Have you ever seen skydivers sailing through the sky? Don't you feel amazed to see them? You might wonder how they control their speed during flight. To understand this, let us first have a look at the concept of drag force. For this, consider two different mediums, that is, vacuum and air. Take an iron ball and a book having same mass of 1 kilogram. Drop them simultaneously in both mediums. We can see that in vacuum, both the objects are falling with the same speed, under the influence of gravitational force. But the ball falling in air is slower than its counterpart in vacuum. Within air medium, the book falls still slower than the ball. Do you know why? Besides gravitational force, the object in air medium experiences collision from air particles. This collision gives rise to a resistant force called air resistance or drag force acting in the direction opposite to the motion. Drag force is given by the equation D is equal to half c rho AV square. Let us now study the factors affecting drag force. 1. A denser medium has more air particles, which increases the probability of collision with the falling body, resulting in a higher drag force. Thus, drag force acting on an object is directly proportional to the density of the medium through which the object is moving. 2. Larger the cross-sectional area exposed to air, more will be the air resistance experienced by it. So drag force acting on an object varies directly with the cross-sectional area of the object. 3. As the speed of the falling body increases, it experiences more collisions with the particles of medium, thereby increasing air resistance acting on the object. Hence, drag force also depends on the relative velocity of the object. Coming back to our previous experiment, as the object falls with constant gravitational acceleration, it keeps attaining more and more velocity. Simultaneously, the drag force acting on the body also keeps on increasing. Once the drag force equals the force due to gravity, the net resultant force acting on the object becomes zero, which means the object no longer accelerates. Rather, it will now fall with constant velocity. This constant velocity attained by the object under free-fall condition is called terminal velocity, Vt, of the object. Its mathematical expression is as Vt is equal to square root of 2 mg by c rho a, where c is the drag coefficient. More the amount of drag force acting on an object, less will be its terminal velocity. Terminal velocity of an object on Earth also varies directly with its mass. Massive bodies have greater terminal velocities and hence fall faster than lighter bodies. Now we are in a position to understand the movement of skydivers. In order to fly at high speed, they reduce their effective surface area, so their terminal velocity gets increased. During their flight, most skydivers attain spread eagle position to maximize their effective surface area, thus lowering their terminal velocity and giving them more time to fall through the sky. The current world record is as high as 614 miles per hour by Joseph Kittinger.